We are fyi sci.
We are fyi sci.
We are fyi sci.
We are fyi sci. Bringing science to you.
Science to you.
Bringing science to you.
Bringing science to you.
The sun is the center of our solar system. And in fact, the word solar comes from the Latin word sol, meaning sun. Although it has been around for 4.6 billion years, throughout human history, the sun has proved to be both critical to life as well as human lifestyle. Many ancient cultures, such as the ancient Egyptians and Aztecs, even worshipped the sun, perhaps due to its impact on crop growth and the warmth and light it provided. Today, it still provides us with light and warmth, and in addition causes vitamin D production that keeps our bones healthy, gives us that nice tan or sunburn, and even governs our modern calendar system, in which one revolution around the sun equals 1 year. But did you know that the sun is also the source of most of the world's energy? Yep, that's right. The sun provides Earth with as much energy every hour as human civilization uses every year. In fact, the Earth intercepts 173,000 terawatts of solar power. And while plants and organisms harness the sun's energy through the process of photosynthesis, humans have been slow to do so too. For example, the use of solar panels as a large-scale source of electric power was only seriously proposed in 1973. Furthermore, since then, the use of solar energy has only gradually become more and more important, accounting for only about 1% of the world's energy consumption today. But how does solar energy work? Simply put, solar panels convert solar energy to electricity. These panels are composed of many smaller units called photovoltaic or solar cells, and these solar cells are composed of two layers of silicon, the N for negative terminus and the P for positive terminus. While the N-type silicon has extra electrons, the P-type silicon has extra holes or spaces for electrons, and the P-N junction that the electrons cross creates the positive and negative charges. As photons from the sun then strike the cell, electrons are knocked free, creating a flow of electricity through conductors that can then be harnessed to power a light, a phone, or even a whole house. For many reasons, solar panels present a good alternative to more commonly used energy sources such as fossil fuels. For starters, solar energy has zero direct carbon and other air pollutant emissions, and although they require resources, the technologies at current installation levels do not measurably contribute to climate change mitigation. In addition, because the rising and setting of the sun is fairly consistent, fairly accurate predictions can be made for the amount of sunlight received daily, and because no one can buy the sun, solar power cannot be monopolized and is therefore cost-effective. It is also important to note that since its creation, there has been a significant decrease in cost of solar energy, costing $500 per watt in 1973, $3 per watt in 2008, and only 50 cents per watt in 2016, making it an increasingly cheaper and therefore a more attractive alternative. Finally, and most surprisingly, in parts of the world like Asia and Africa that are not yet on the grid, solar energy actually serves as the cheapest means of electrical generation and distribution infrastructure. And the fact that Africa also has 7 of the 10 sunniest countries on Earth makes solar an even more viable option under the circumstances. That being said, there are definitely limitations to solar energy. Most obviously, the sun doesn't shine 24 hours a day, and weather varies from place to place, and therefore solar in its current generation cannot be the sole source of energy. More specifically, the infrastructure to move solar energy from where it is generated to where there is demand does not yet exist and would be expensive to build, and current solar energy storage technology is also still too expensive and inefficient to justify large-scale implementation. Therefore, development of effective and low-cost storage technologies, as well as means of getting electricity from sunny spots to cloudy ones, is required in order to increase the attractiveness and value of solar energy. This all being said, Regardless of the scale or speed in which solar panels are implemented, improvements in technology are taking place at a rapid rate, and it is inevitable that solar energy will continue to play a significant part in the moving away from our current reliance on fossil fuels. Even in its current generation, solar energy has major benefits, and, if anything, it is important to remember that the potential cost of climate change will more than justify the investments required to make solar an even more viable technology.